Hey everyone, and welcome. So, if you're an engineering diploma student in Assam, you've definitely come to the right place. The State Council for Technical Education has rolled out a completely new syllabus, and we're here to break down exactly what that means for you. Let's dive right in and see what's in store for your second semester. So, you've made it through your first semester. Congrats! And now you're gearing up for the next one. But hold on, things are going to be a little different this time around. We're talking a new structure, a new grading system, and a ton of new opportunities. The big question is, what's actually changed and how is it going to affect you? Well, let's find out. We've laid everything out for you in 5 simple sections. First, we're going to look at the why behind all these changes. Then, we'll map out the new structure of your diploma and your semester. After that, and I know you'll want to pay attention to this, we'll get into the details of how your grades work, peek at your courses, and finally, look at all the cool stuff you'll be doing outside the classroom. Okay, let's kick things off with Section 1, a new era in education. It's really important to get this. These changes aren't just happening at your college or even just in Assam. Nope, this is all part of a huge nationwide shift in how we approach education. The main engine driving all of this is the National Education Policy, or NEP, from 2020. The whole point of the NEP is to make education in India more modern, a lot more flexible, and way better suited for the challenges of, the 21st century. Your new syllabus, it's a direct result of that big, forward-thinking idea. So what's in it for you? Well, you're getting a ton more flexibility thanks to something called the choice-based credit system. You're also getting real-world, hands-on experience through mandatory internships. The old walls between engineering streams, they're coming down, and you'll see some really cool new courses on things like design thinking and entrepreneurship. It's all about clear goals and using awesome modern tools like virtual labs to help you get there. Okay, moving on to Section 2, your semester blueprint. Right, let's get into the nitty-gritty of how your entire 3-year diploma program is now pieced together and what this whole credit system actually looks like. This chart is a fantastic snapshot of your entire diploma journey. As you can see, the biggest piece of the pie, 45 credits, is your program core. That's your main branch subjects. But look at the other big chunks. Almost 20 credits in basic sciences, 15 in engineering sciences, and a solid 12 credits just for projects and internships. This really shows you how the program is designed to give you both strong fundamentals and practical hands-on skills. So, what's the magic number you need to remember? It's 120. Over the next 3 years, this is the total number of credits you'll need to rack up to get that diploma. Think of it as your finish line. Every single course you pass gets you one step closer to that goal. We mentioned the choice-based credit system, or CBCS, a minute ago. So what is it exactly? Well, to put it simply, it's a system that gives you more freedom. It allows you to have more of a say in your own learning path, especially with electives, letting you explore subjects that you're genuinely curious about, all while you're still hitting your core requirements. And here it is, your second semester all laid out. You'll be taking on a total of 20 credits. You've got some heavy hitters like mathematics and applied physics, along with those foundational engineering subjects, and notice the mix here. For every big theory course, there's a corresponding lab, which is absolutely crucial. Oh, and see environmental science down at the bottom? That's a mandatory audit course. It doesn't give you any credits, but you still have to pass it. All right, and now for the section I know you've all been waiting for. Section 3, how your grades work. You're going to want to pay close attention here because this is exactly how you'll be marked and evaluated from now on. This is a super important slide. For your theory classes, your internal assessments, that's your tests, assignments, attendance, that's worth 40% of your grade. The big final exam at the end of the semester is worth 60%. But look at the practical courses. It's completely flipped. Your continuous work in the lab makes up a massive 60% of your grade, and the final practical exam is only 40%. This means your consistent day-to-day effort in the labs is now more important than ever. Now, this next point is critical, and I want you to read this quote very carefully. This is pulled directly from the official SCTE document. You must pass your internals separately. If you fail the internal part of any course, you will not even be allowed to sit for the final exam in that subject. Just let that sink in for a second. Your work all semester long isn't just practice, it's literally your ticket to the final exam. The grading system itself is now what's called an absolute system, which is great news because it's so straightforward. Your marks translate directly to a grade and a grade point. There's no bell curve, no complicated formula. If you earn the marks, you get the grade. Simple as that. A score of 40 is the minimum you need to pass, and that gets you a D grade and 4 grade points. And get this, your attendance now literally converts directly into marks for your internal assessment in theory courses. Out of those 40 internal marks, a full 5 of them are just for showing up. If you have 96% attendance or higher, you get all 5 marks, guaranteed. It's a pretty clear incentive to be in class and engage with the material every single day. All right, let's keep it moving. On to Section 4, your second semester courses. We've seen the full list, but let's take a quick peek inside a couple of the most important ones to get a feel for what you'll actually be studying. So, in Mathematics 2, you're going to be building heavily on what you already know. You'll dive deep into coordinate geometry, not just in 2D, but in 3D, which is so important for modeling things in the real world. And then you've got the 2 huge pillars of calculus: differentiation, which helps you understand rates of change, and integration, which is used for calculating things like area and volume. This is all foundational stuff for any engineer, for sure. Applied Physics 2 looks just as exciting. You'll be covering the fundamental properties of materials, how they stretch, bend, and flow. You'll study the physics of waves, from the simple motion of a pendulum to how sound works. You'll also explore the world of light, including the amazing tech behind optical fibers, and even get an intro to modern physics, looking at everything from the photoelectric effect to what makes lasers possible. Okay, let's wrap this up with our final section, Section 5, Beyond the Classroom. Because your education under this new system isn't just about what happens in lectures and labs. It's about getting you ready for the professional world. Every single semester, your college is now required to set up at least one industrial visit, so you can see real engineering in action. You'll also get at least one guest lecture from an expert who's actually working in the industry. These aren't optional, they're mandatory activities designed to connect what you learn in class to what happens in the real world. And this slide really brings it all home. This is a logo for the State Council for Technical Education, Assam, and its motto is Technology for Self-Reliance. Every single change we've talked about today, the flexible credits, the focus on practicals, the industry visits, it is all aimed at this one powerful goal: to give you the skills and the knowledge to be a self-reliant professional. So we want to leave you with a question. This new syllabus isn't just something that's happening to you, it's really a framework of opportunities. It gives you more choices, more real-world exposure, and a much clearer path to a great career. So the real question is, how are you going to use it to build the future that you want?